Chavi Ruchika beta, we will cover number 32, 33, 34, and 35. So we'll cover 4 question types. There are not that many questions in each one of them for us to solve, but they all present a slightly different scenario. So let's start with number 32. So in 32, what do we have? So let me go inside the question type 32. So here we will have a projectile that goes and that undergoes an abrupt change in its path or in its motion. So as you will see in the diagram that will pop up in just a minute, you will have a projectile or a particle that is dropped vertically downwards, and at some point in its trajectory, it hits a wedge, and after hitting the wedge, its velocity is going to undergo a change in direction and magnitude, and that depends on what kind of collision it was, whether it is an elastic collision, inelastic collision, the wedge angle. It will depend on all those factors. So when you are writing your equation of kinematics, right? So x is equals to ut, y is equals to ut plus square. You'll write those two equations for the two segments separately, right? There is no confusion, no? So you cannot have one continuous equation for the entire journey. You will have to write those equations separately for the two segments. What is the other thing? At that point where we have the change in the an abrupt change in the direction or the velocity of the particle, like for example here in this scenario. So once again we will write the equation of motion for this segment separately, and we'll write for this separately. And at this point, whatever we know about that interaction, we will use that to define our conditions, initial conditions, final conditions, right? So let's take one as an example. So let's solve this question. So let me read through it. It says a body falling freely from a given height h hits an inclined plane in its path at a height h. Let me draw this as well. Let's say the particle is dropped from a height h. It hits the plane at a height h. So this height is given to be h. I hope my interpretation is right. As a result of this impact, the direction of the velocity of the body becomes horizontal. For what value of h by h, the body will take maximum time to reach the ground? For what value of h by h, for what value of h by h, the body will take maximum time to reach the ground? You might need my help a little bit to try and figure out the horizontal velocity after the collision. But first, think through it, and then we'll have a discussion. So let me quickly check on the YouTube here. Hi Abhimanyu, I see your message, beta. So we are we are covering the projectile motion. And in the projectile motion, we are looking at scenarios wherein the particle undergoes an abrupt change in its path, and we have to figure out the unknown based on what's given in the question. So, beta, give it a try. Try and solve the question that's in front of you. That's a JEE Advanced question from 1986. And after a minute or two, after the class has given it some attempt, some effort, then we'll discuss the question and then we'll move on to the next question. So I'll go back in the live class. Yes, Chavi, Ruchika beta.
So 1/2. I'm not sure, but मेरा 1/2 आ रहा है.
1/2, okay. So if I may ask, beta, how did you determine the horizontal velocity, or did you not even need to find the horizontal velocity?
Sir, I didn't need to find the horizontal velocity.
Okay, good. So, Chavi beta, I hope I have not confused things by talking about the horizontal component of the velocity. So let me start discussing it. Chavi, is that okay, beta, if I start discussing it?
Yes.
Okay. So Ruchika is right that as far as the particle after the collision, when the velocity becomes horizontal, it will trace the path like this. Correct, Nobita? Now, the how much time does it take? Right, the body will take for the what value of h by h, the body will take maximum time to reach the ground. So let's understand what is determining that time. Right, is it does the horizontal component of the velocity, does it have any impact or any effect on how much time will the particle take to travel this distance? No. Correct? No. Why do I say that? So for this second segment, so this is my first segment of the journey. This is my second segment of the journey. For the second segment of the journey, my y is equals to the initial velocity in the vertical direction is 0, t2 plus half g t2 square. That means h is equals to half g t2 square, or t2 is equals to square root of 2h by g. Let's think about t1. How much time will the particle take to reach this new height h? Or in other words, how much time will the particle take to cover height h minus h, or to cover the distance h minus h? And I think the body falling freely from a given height. So it's in a free fall. That means it is moving under the acceleration g. And does it say that it has been released from? Okay, so I'll assume that the velocity at the topmost point is 0. The body falling freely from a given height. Okay, so the initial velocity I'll assume to be 0. So in which case, h minus h, the distance covered in the first segment, is equals to, again, 0 times t1 plus half g t1 square. Is that right, Peter? So h minus h square root 2 by g is equals to t1. Now, what is the total time? Total time is t1 plus t2. That is, I'm going to take square root 2 by g out from both the terms. So we get square root h plus square root of h minus h. We want this total time to be maximum. And what is the total time? Total time is a function of the small h. Now, this is something that you will learn repeatedly as we do similar problems in the upcoming chapters as well. So whenever we have such a scenario where y, some function, some variable is dependent on, say, let's say the variable x, right? Then how do we find the points of x for which the particle, or for which y is extremum, that means either maximum or minimum? Well, you try and find the slope dy by dx and find out for all the values of x where dy by dx is 0. Once you get that value, then you know these are the points where you have either maxima or minima. For maxima, then you take the derivative one more time, that is d2y by dx2, and see if it is negative for maxima or if it is positive for minima. So in this case, if I take the derivative of t with respect to h, so dt by dh, there'll be 1 by 2 square root h, and there'll be 1 at the top, plus 1 by 2 square root of h minus h, and then derivative of h minus h, which will be minus 1. So in other words, we'll have this scenario. So this should be equals to 0. So what does this give us? This implies that square root of h is equals to square root of h minus h. I'm going to square both the sides, the left hand side and the right hand side. What do we get? H is equals to h minus h, or h is equals to h by 2. In other words, h by capital H is 1 by 2. Chavi, is that okay, beta? Yes, beta?
So what differentiate जब हम कर रहे थे, we had multiplied it by some constant, right? Like the root 2g, वो कहाँ गया?
Yes, I let go of that because you're gonna equate it to 0. Right?
Okay, हाँ, sir, right.
That's why I didn't write it. But yes, to be technically correct, I should have written it like this. Yes, beta?
Right, sir.
Okay. Clear?
Yes, sir.
Okay. Let's do another problem. This is on the advanced level, JEE advanced practice questions. So please solve number 59. And limited time, I'll request you guys to hurry up, and then after 2 minutes, I'll start discussing the question. So frame up your thought process on how you're going to approach it, even if you're not able to complete all the steps. Question number 59. Let me quickly recap the question. So what is the question saying? The ball is thrown from the ground towards a vertical wall in such a way that the motion plane of ball makes an angle of 30 degrees with normal to ball. That means with a normal to the ball. That means this angle is 30 degrees. Is that clear? And this distance OA is given to be 4√3 meters. They're asking for this distance. For students on YouTube, I think this is a fairly good question. So if I were to try and provide a hint, at the collision point, at the point P, think about the three components of the velocities, right? The vertical component, the component perpendicular to the wall, and component that is tangential, that is parallel to the wall, or horizontal component parallel to the two components of velocities will not change as a result of the collision. Which ones? The component of the velocity in the vertical direction and the component of the velocity that is horizontal and parallel to the wall. So what does that mean? So that means that by the way, and the collision is given to be elastic. Just quickly, yeah. So the collision is elastic. So which means that the velocity, the component of the velocity perpendicular to the wall going in is the same component coming out. In other words, nothing has changed. It's just that think about if it had not hit it, the particle would be traveling like this. So whatever the component of the velocity, that has just been, the direction of that has just been changed. That's all. Right? So the overall range, whatever the overall range was, so this distance OA plus AQ will be equals to R. And if you think about the AQ, what angle does it make with the normal to the wall? It should make the same angle, as the OA, because that all depends on the horizontal velocity. So let me go back into the live class. So Chavi, Ruchika, any ideas, beta? Can we quickly discuss it?
सर एक आइडिया था but I am like almost sure that it does not make too much sense.
Okay, what was it, beta?
सर तो अगर हम ऐसे if we know that like I'm pretty sure like if you hit a ball at an angle of 30 degrees,
Yeah.
it'll rebound also at an angle of 30 degrees, right? Because it's an elastic collision. So can we assume कि अगर if we look at it from the signs from the front, it'll kind of make an isosceles triangle, and then we know that the side के angle is 30 degrees, and if we find the height, we can find the base.
See, here in this picture, some information has not been clearly given, right? So what is not given? What is not given is at the point where it hits it. In the diagram, it does indicate as if the vertical component of the velocity is zero at that point. It doesn't say that anywhere in the text. So if you were to assume that, then what you are saying is right. Which means the particle actually undergoes collision at the topmost point. This is where the particle is undergoing collision. Now, let's understand something this is important. So if you think about the velocity, so going in the velocity, if it is horizontal, if it was vertical, let's say it had component in X, Y, and Z direction. That means it had component along the wall, it had component like this, and it had component like that. Right? This is the velocity components. I'm calling, let's say, perpendicular to the wall as X, along the horizontal and along the wall is Y, and the vertical direction is Z. Then after the collision, let me change the color. If only it allows me to change the color. There we go. So after the collision, what will we have? This component will not change. This component will not change. This component will reverse as it is. Okay. So now, as far as the OA is concerned, what angle the wall? Yes, beta.
Sir, is the answer 8 meters?
Is the answer 8 meters?
Yes.
Okay. This is 4 root 3. This is 4 root 3. This is 60 degrees. Then this should be 4 root 3. How have you approached it, beta? How have you approached it?
Sir, I drew the diagram, and sir, I was getting, since the distance of the point of projection from the wall is 4 root 3, so it's normal distance. I took 4 root 3 to be the normal distance rather than the actual distance.
Oh, you took the normal distance as, does it say that? Distance of point of projection from wall is 4 root 3. It very well might be.
Sir, because it is not from where it hits the...
Right. And whenever they provide just the distance, it typically is the shortest distance. In which case, if this is 4 root 3, then OA will be how much? So we have, this is 30 degrees. So OA cos 30 is 4 root 3. So OA is 8. In that case, yes, it will be 8. But the rest of the logic is the same. So beta, have you guys observed that this angle 30 depends on the component Vx and Vy? Right, na beta? Yes, Chavi? So let's say this was Vx, correct? Or sorry, this was the horizontal velocity, and this will undergo change like this. this angle has to be the same as this angle. Yes, Peter? Hope that made sense. If not, let me know. Chavi, Peter, did it make sense? Acknowledge quickly, please, so that we can move on.
Sir, I didn't get it.
Peter, your voice has disappeared.
Hello, sir.
Yes, Peter.
हाँ समझ ये वाला पार्ट नहीं समझ आया.
Okay. So let's look at it. I'm going to look at from the very top, right? So I'm going to view the entire situation looking from the top, right? So this is how it will look like. So I'm just drawing this boundary from the top. So what do we see? This is my point origin O. This is my A. The ball goes and hits there and then comes back. Well, this angle is determined by what? If the velocity.
The initial angle.
This is not the angle of projection, beta. We are looking, this is the entire thing is the horizontal plane, right? We're looking from the top. So this is my, let's say, I'm going to change the color one more time. So I'm going to call this as my X direction and this is my Y direction. And the vertical direction is the Z direction. X and Y are both in the horizontal direction. X and Y both are in the horizontal direction. And my velocity is in this direction. Okay. So then what is this angle? Theta. Well, this is my Vy, this is Vx. So the tan theta is Vy by Vx. Simple, no? After the collision, your Vx remains the same. Vy changes in direction, right? This becomes Vy. So this becomes a new V. So what is the angle? This angle, let's call it alpha. So once again, tangent alpha is, sorry, I've used so this angle is theta. That's correct. This is theta, this is alpha. So what is tan alpha? Tan alpha is Vx by Vy, which is same as where have I switched the angles? So tangent alpha is Vx by Vy. And what is this angle? So this angle is also theta, right? So this theta, and this angle is Vx. Sorry, here I've written it wrong. This is Vy beta. Horizontal is Vy, this is Vx. So tan alpha is Vy by Vx. Let me erase it. Vy by Vx. It's equals to tangent theta. That means the angle 30 degrees, alpha is 30 degrees, given that theta is 30 degrees. And did that make sense, Peter, now?
Sir, okay.
Yeah. And what we are looking at is, looking at the diagram, seems like it's shown that just the entire collision is happening in the horizontal plane. That's how it seems like. So we'll assume that the particle hits the wall when it has reached its maximum height, right? So which means that the distance covered OA is half the range. In other words, if you think about the entire projectile motion, the entire path has been folded into two, right? This entire R has been folded into two, shown here. Anyway, let's move on. Let's go to the next type of question. So now in this scenario, what we have is we have a particle which is moving in the horizontal plane as well as the vertical plane. And the two motions are independent. So to be more precise, what has been given is that a particle is moving to think of imagine a vertical cylinder. Imagine a vertical cylinder, a smooth vertical cylinder, and a particle has been projected with some velocity tangential to the cylindrical wall in the horizontal direction, and the particle is moving around, was moving with that constant speed in the horizontal plane, but because of the gravitational pull downwards, it's starting to descend downwards. Yes, beta. So what will happen is the particle will move like this, as shown here. It will follow a helical path. And interestingly, the pitch of the helix will keep increasing. Yes? Why? Can somebody explain why the pitch? What is the pitch? Pitch is the distance moved by the particle along, let's say in this scenario, in the vertical direction, by the time it completes one rotation in the horizontal plane. Right? So if you look from above, you will notice that particle starting from here comes back just below this position. So from the top, it will look like the particle has completed one circle. But actually, this point is slightly vertically downwards. So it is not at the same point. As it's moving further and further downwards, the velocity in the vertical direction is constantly increasing because the particle is moving downwards with the acceleration g, that is 9.8 meter per second square. So its velocity is increasing at 9.8 meter per second rate. So that's why the pitch, which is the distance covered by the particle in the vertical direction, by the time it makes one complete rotation, that is increasing. Does it make sense?
Yes, sir.
Now, if I were to tell you that this is no different than the projectile motion, right? Will that sound strange? So let me explain. So in the projectile motion, what do we have? So we have a particle which is moving in the horizontal direction, in the horizontal plane, and particle is also moving in the vertical direction. In the vertical direction, it is moving under a constant acceleration. That is the acceleration due to gravity, that is g, 10 meter per second square, 9.8 meter per second square. In the horizontal direction, in the absence of any wind resistance or any wind blowing or anything else, any dissipative forces, the particle will continue to move with the same speed in the horizontal direction. And it is our good fortune on this planet Earth that the motion in two perpendicular direction, they are independent of each other, and we don't have to worry g in the vertical direction impacting the motion in the horizontal, right? So what does that mean? We write in the projectile motion scenario, we write the motion equation independently in the horizontal direction. We say x is equals to uxt. And then we have our equations for the vertical direction. That is Vy is equals to Ui minus Gt, and y is equals to Uyt minus half Gt square. Correct, Nobita? Only thing that's connecting the two is your time t. Right? Correct? So the only thing that's connecting the two is time t. Hi, good evening. So Guru, I see your message, beta. So we are talking about the projectile motion, and we're covering an interesting scenario wherein the motion is actually circular and with the particle moving, descending downwards, but it's very similar to the projectile motion. So I'm going to go back into the live class. So so from that perspective, if you think about this motion, instead of moving in a straight line, which is what you expect in the projectile, here it's moving in a circular path, right? In a circular path. Now, in the vertical direction, we continue to move with the same equations. Vy is equals to Ui minus Gt, and the y is equals to Uyt minus half Gt square. Would you guys agree, Chavi, Ruchika? Yes, Peter?
Yes.
Chavi, is it making sense, Peter?
Yes, sir.
Okay, so if I were to ask you what is the pitch, how would you find the pitch? That is, but then you have to ask me, sir, pitch at what time? Because pitch is continuously changing, right? So maybe that is not a valid question, right? So pitch is continuously changing, it's increasing. Correct, Peter?
Yes, sir.
Right. So let's
तो सर इसमें तो नॉर्मल सॉरी सर
So let's take this question as an example, right? And hopefully that will help us apply what we have learned and see if it makes better sense. Do you guys want to give this question a try? Let's give it a try. There's only one question that we have for this question time. Please go ahead and solve this one. Only take 2 minutes, please. Yes, beta. So, Guru, I did see the message that you mentioned that you were struggling with the studies. I am not sure, beta, if you are preparing for the JEE exam or some other exam. And if you are preparing for the JEE exam, are you preparing for 2023 or 2024? But to answer your question about not being able to focus on studies, I do want to point out something fairly simple. First of all, this is nothing to do with you per se. Our minds are not built to be solving physics, chemistry, maths by design. We are very much outdoorsy people, right? Our minds are designed differently. So why do we not feel, or why are we not so much focused in our studies? Because beta, the minds find it difficult to engage because the subject is new. It feels hard. So it would rather watch YouTube videos, do something else, play a game, talk with friends, whatever it might want to do, but it has no intention of interacting with physics, chemistry, maths, where the subject seems scary. So by design, wherever there is fear, whenever there is a fear or a dislike for something, the mind would not want to engage in that field. So what can you do about it? Well, beta, the reverse trick is if you take small steps, have small wins. That means you are able to solve a few questions, right? In physics, solve a few things in chemistry. So for that, either you can take some help initially with your friends or the coach or the teacher, or if you have enough determination that, hey, I'm going to fight it out and I'm going to spend enough time needed for me to start grasping the subject. The trick is, if you can stay with the subject for long enough, the mind will start to figure it out. It's just not possible.
Answer C option.
Okay, so beta, I hope you got the message. Just not possible that a mind will not learn. It will learn. Just stay there with the subject for some time. So let me go back into the class. So you said beta, C is the correct option?
Yes, no.
Okay. Shall I quickly solve this question? So I think the question is asking how many number of revolutions are made by the particle by the time it exits the cylinder. Is that right?
नहीं सर हो गया
Okay, no? Okay, so just to recap, so to cover this distance h, we will use h is equals to 0 times t plus half gt square. So time taken is square root of 2h by g. Now the question is saying in this time, how many revolutions does it make? Well, we know the time period for one revolution is 2 pi r circumference divided by the speed, which is v0. So this is for one revolution. This is the total time. So if you divide the two, you'll get your number of revolutions. Let's move to the next question type. So here what we have is two particles undergoing collision during the flight, mid-flight. Okay. So what is the important thing about such questions? When the two particles meet at, say, some point, let's say xc and yc, then note that these coordinates xc and yc, they will satisfy the equation of trajectory for both the particles, right? So if you write down your equation of trajectory for both the particles and then substitute xc and yc in each one of them, so you'll get two equations in two unknowns. What are the unknowns? Xc and yc. So you should be able to solve for the point at which the two particles or two projectiles will meet. If you are asked for something else, right, after how much time will they meet, then if once you know the coordinates, you can quickly figure out your time working backwards, right? So there are different ways to solve it. So let's go ahead and take an example. This will take a little bit longer. So let's solve this question. So we'll look at the anti-abhyas question. Let me read through it with you guys, just for in the interest of time. It says a particle A is projected from the ground with an initial velocity of 10 meters per second at an angle 60 degrees with the horizontal. From what height in meters, directly above the point of projection of the particle A, should another particle B be projected horizontally with velocity 5 meters per second so that both the particles collide right before they strike the ground, right before they strike the ground. So beta, please go ahead and solve it at your will, and I'm gonna sketch it out and solve the question with you guys. For the students on the YouTube, it's if I were to provide a hint, it's fairly simple and straightforward. We know that the two particles strike by the time the particle A is about to hit the ground. So you know the time of flight then, right? And the time of flight would be 2u sine theta by g, right? So 2u sine theta by g. So that is the amount of time for which the two particles will be in the flight. Now, for this time period, the particle has to descend a height h, right? So if I were to write, so the time of flight t is equals to 2u sine theta by g, and theta u is 10 meters per second, and sine 60. So that is root 3 seconds. So the particle B has to descend by a height h. So y is equals to ut plus half at square. Since it does not have any component of the initial velocity in the vertical direction, so I can write 0t plus half g t square. In fact, I should write capital T.
So is it 15 meters?
You said 15 meters, is it?
Yes, sir.
Okay. Hello, Manan. But that's what I'm getting as well. So how are you doing, Manan? All well?
Yes, sir.
Okay, beta. So beta, we are about to close it out. So we have another question type to go, and then but you and I can catch up some other time as well and discuss overall some of the focus areas for kinematics chapter. But I would highly recommend those JEE advanced practice questions, beta. I think you should take an attempt at.
Yes, sir.
Chavi, you're done, beta?
So एक second.
Sure.
हाँ सर हो गया.
Okay. Let's move on to the next question type. And this is the last question type for the day. So if the two projectiles, in fact, the last question has some of the things from this question type. So here we will look at the scenarios wherein the two projectiles have the same horizontal velocity. So what does it mean? That if the two particles at certain time t, let's say at initial time t equals to 0, they are vertically above each other, then they will always remain vertically above each other. Is that understood? Yes, beta?
हाँ sir.
Okay. So for example, if a fighter pilot, or if not a fighter pilot, let's think of a helicopter pilot, right? So if the helicopter is flying at a certain height, with some velocity u, and it drops a packet at that point, and the intention is for the pilot to hit the object, whatever. Let's say there is a wagon, or there is some kind of a car at the moving with the same horizontal velocity. Then the two will sure are bound to meet, right? Because they'll be covering the same distance in the horizontal direction. Fairly simple and straightforward. Yes? Correct, Peter?
Yes sir.
By the way, have you guys heard of this standard question that you would see in many places, that if, let's say, a gunman who's trying to shoot this target, right? And if he knows that as soon as he fires the gun, this cord will be cut, then where should he aim? He should always aim directly at this object. Okay? Have you guys understood what I'm trying to say? Once again, if you have to hit a target which you know that it'll be, so let me put it differently, right? So have you guys seen people taking the buck shots, right? So they shoot a buck in the air, and you have people with the rifles, they will come and shoot the buck, right? So the trick is to aim it at the highest point, right? At the highest point of its trajectory. So let me come back to this one, and it'll make sense to you guys. So let's say at time t equals to 0, you fire this gun with certain velocity v, and at the same time, this part starts to fall freely, right? So the question is, will the bullet hit this target? Will the bullet hit the target? By the way, there is a acceleration due to gravity in this direction, g. So the bullet will actually follow this path. So the answer is yes, it will hit that target. Can you guys explain why that will be? Chavi, better, can you explain? Ruchika, Manan, can you guys explain better why that is the case? Why will the bullet hit the target? Just write down your equations. It will start to make sense, right? Because half gt square, that half gt square term is common in both. Use the relative velocity concept if that makes, or the relative or maybe let's not worry about the relative velocity. Let's just try and solve it simply in the reference frame attached to the top, right? So let's say this is the height h. The rifle is aimed at the target, right? And then at t equals to 0, the bullet is fired, and at the same time, the particle or the object starts to fall down. So, so if I were to write down the equations, so what will that be? So the equation would be so this is my height h, and let's say this is the distance d, and the angle at which you fire the gun is theta. Then what will be the vertical distance covered by the time the bullet reaches at this end? Well, that'll be let me call this y is equals to v sine theta t minus half gt square, right, Peter? And what is the distance? This distance, let me call it small h. What is the small h? Small h is half gt square, right, Peter? Correct? So any ideas on how to proceed further from here to make that conclusion? So what are we trying to prove? That y plus h will be equals to capital H as long as v cos theta into t is equals to this distance d. And what we are already given is that tangent theta is by d. Because remember the gun is pointed in the direction of the object. So tan theta is h by d, that's given. So from here, can we prove that that's the scenario, beta? So if I do y plus h, what is it? Y plus h from these two equations? Simply v sine theta t. Right, beta? If I divide the two equations, so I get tan theta. Right, beta? And tan theta is the h by d. Which means y plus h must be capital H. Maybe I could have found a better way to explain it, but do you guys get some understanding of what's going on, beta? Chavi?
Yes.
Okay, Ruchika, you got it? Okay. Manan, clear na, beta?
Yes, sir.
So we'll take a break now. We'll stop the class and we'll carry on with the chemistry class. And Manan, beta, I'll see you tomorrow, okay? Or on Wednesday.
Okay, sir.
Alrighty, beta. So Chavi, Ruchika, do you guys want to hang on for organic chemistry?
Yes, sir.
Okay, give me a quick second.
Oh, so can you give me like 2 minutes? I'll be back.
Sure, beta, sure. Take your time. So for the students on the YouTube, so that's it for today. Do keep practicing, but it's all about understanding the different concepts or different types of applications for your concepts to get a better grasp of it. So hopefully the questions we solved today will help you to get a better understanding. But stay tuned, and we'll carry on with these classes from Monday to